So here we are in the Crawford Observatory in UCC, and you might well have heard of some interesting solar activity in the newspapers over the last few days. And my name is Paul Callanan, and we're going to talk a little bit about how these solar flares can affect satellites and even activity here on the surface of the Earth. Solar flares are very energetic phenomena that occur near the surface of the Sun. Whether they happen or not depends on whether the Sun is going through a period of activity. The Sun goes through cyclical changes in its activity every 11 years or so. It's just now coming out of a cycle of 11 years of quiescence, and it's just beginning to become active for the first time again. The flares happen because of magnetic fields near the surface of the Sun becoming entangled in themselves and generating a lot of energy, which can be used to accelerate particles and to make radiation flood out from the Sun across the solar system. About 19 years before, indeed, the observatory here was built, an astronomer called Carrington observed the first solar flare in England. It was an incredibly bright and powerful flare that gained attention worldwide at the time. It was so bright, for example, that it actually caused telegraph wires to go on fire. Such was the energy of the solar flare as it affected the telecommunications systems of the day. And we've been observing solar flares ever since. Nowadays, of course, they're monitored very closely by a series of satellites that we have monitoring the Sun. The activity that we're experiencing from the Sun right now has a certain cyclical nature. The Sun, it turns out, has a cycle of about 11 years between periods where it's relatively inactive and where it suddenly becomes very active again. Periods of activity usually start with the presence of sunspots occurring on the surface of the Sun. And after that, then, there's very often the occurrence of these flares where radiation gets emitted from the surface of the Sun and high energy particles also, which we experience. We can measure these here on the Earth as well. Well, aside from the effects we were talking about earlier with the way that solar flares can affect telecommunication systems here on the Earth, they can affect satellites and rockets in space too. These satellites, for example, orbiting the Earth are more exposed to the effects of this radiation than we would be here on the surface. And so some of these satellites, for example, during flares can be damaged or knocked out of action. Telecommunication satellites and even GPS satellites can be rendered inoperable for periods of time during flares. There's also an effect that it could have on humans, any humans orbiting the Earth at the time as well, because some of the radiation from these flares consists of very high energy particles like high energy protons, and these can actually have an effect on humans. And so astronauts, for example, in the future, if they were traveling from the Earth to Mars, would have to retreat into specially protected parts of their spacecraft during solar flares just to protect them from the effects of this kind of radiation. So these solar flares occur near the surface of the Sun. We think the main reason that they occur is because we can observe regions, especially when the Sun is active, containing very strong magnetic fields. And these magnetic fields can be so strong that they suspend very hot gas outside the surface of the Sun. And if the Sun is very active, these loops and fields can get twisted up together, and this can result in a very quick, very sudden, almost catastrophic release of energy. This energy is transferred into particles which are then accelerated across the solar system, and some of them actually reach the Earth. In addition, the flares release an awful lot of electromagnetic energy, like X-rays, for example, which we can also observe at the Earth or by satellites, with satellites orbiting the Earth. If the Earth didn't have its own magnetic field, then the effect of this radiation on the Earth could be very significant. But luckily we have a protective magnetic shield around us, which deflects an awful lot of this radiation and prevents most of it from having any effect near the surface of the Earth, aside from effects on the electricity supplies and telecommunication systems, occasionally for the most dramatic flares. However, some of the particles, once they meet the magnetic field of the Earth, can spiral along the magnetic field lines and reach the poles, very near the poles of the Earth, both in the north and southern hemisphere. And when they do that and reach the outer part of the Earth's atmosphere, their energy excites molecules in the Earth's atmosphere, giving rise to the aurora that we can observe. And so these aurora may become a more regular series of events over the next few years, because, as I was saying, the current activity cycle of the Sun is only just beginning, and so we can expect many more of these active flares to create these spectacular displays over the next few years. And maybe some of them might even be visible again from Ireland.